kind of have an idea of where we're going with this. But notice you're provided a model. In this model, it represents the amount of money spent on online advertising. And T is years. It gives you an example. T equals 11 represents the year 2011. Notice that T is being restricted over here. It says like T has to be between 11 and 15. And the reason for that is like that's when the model is like really good. We have to like realize like when we make models for things in the real world, it may not extend forever. So there might be like a time when it doesn't work anymore. Like if you think about a model in the 1950s for the number of color TVs sold, that probably was growing really, really fast. And then maybe it's less now that we all have color TVs. Okay, so things change in the world, so your model changes. So don't let that domain restriction really mess with you. It's just saying like this is when the model is good for. How did you guys decide to answer question A? Yeah, plug 13 in for T. Thank you. So S equals 9.30 e to the 0.1129 times 13. You're just evaluating that. How much money are we spending there? 40.35, 40.4, either one of those is fine with me. $1 billion, right? Not $40.35, but 40.35 billion. So you should have that label there. In what year did the U.S. spend $80 billion? What did you guys do in an attempt to solve that question? Plug 80 in for S, the amount of spending. So, like, one thing that you'll need to be thinking about as you're doing your homework tonight is, you know, like, what's an appropriate substitution? Should I be substituting in for time? Should I be substituting in for the amount spent? So here, you've now created one of those equations that you were just solving on your homework from Monday. So I see exponential. I want to isolate the base and the exponent. That would mean I want to get e to the 0.1129 by itself. So I'm going to divide by 9.3. Whatever I get, I'm just going to call it 80 divided by 9.3 for right now. I now have the base raised to an exponent all by itself, so I'm ready to rewrite it in a logarithmic form so I can break into the exponent there. If I'm doing a log base e, what type of log is that? Natural log of whatever 80 divided by 9.3 is. And that equals the exponent. Remember, the answer to the logarithm will always be your exponent, so 0.1129t. And then finally divide everything by 0.1129. So you type this in your calculator. How many years is that? 19. I think it's like 19.06, 19.1, something like that. Okay. Now, really important with the modeling questions is, have you answered the question that's being asked? So what does that question actually ask you? In what year? If it's 19.06, that's in 2019. Since it's a little bit over, it's probably like early in the year. In January, we reached that 80 billion mark, and then throughout the year, we continue to earn more money. Okay. So you'll have to be really careful. Like if that came out to be 18.98, that would actually be in the year 2018. Instead of rounding up to 19, you would want to say it happens before 2019 that I reach $80 billion. Okay, so always be careful and make sure you're answering the question that's being asked. Okay, let's go on with our notes for today. We're talking exponential and logarithmic models. So the first example is a financial question, which we have worked with these types of questions before. So when it talks about how much you're investing, at what rate, and interest being compounded, what are you thinking about? Okay, you might be thinking about A equals the the principal times 1 plus r over n raised to the n times t. Or in part B, if you're compounding continuously, part. So again, I'm going to give you a little bit of time. See if you can set these up. You can talk to your group members, toss ideas out, see if you're getting the same answer. Okay, and then I'll go over them in a couple minutes. So see what you can get done in that time. Why are you putting 2 times 1,000 there? It is supposed to double. So what would the doubled amount represent in the formula? The what? No. I like where you were going. Really focus on the things in the formula and like where you can plug in. I'm just gonna let you think about it before I just give it away. I like that a lot. You should probably have an exponent on yours, right? Finish it out so that you have something to solve for. So you can have all numbers. So what is your n value? R divided by n. So it should be 4t to the top because you're trying to solve for time. So that means that you're solving for something in the exponent. You cannot multiply because it has an exponent. So exponent works. That's why you did yesterday's work, which is solving an equation. I'm not sure if you evaluated your log incorrectly. Oh, you're missing your question you start with. Why would you do that? So be real careful here. You are not allowed to multiply these things because this one has an exponent, which you can't do. So that's why you have like the solving. You're going to be solving for t and the exponent. So you're going to be lost at some point. But there's some other bit of information. So if you read this statement, you know either A or T. Yeah. Yeah. Okay, so I'm going to go ahead and work these out so we can move on to our other examples. Okay, if you read the problem, you're going to pick out the stuff that you know, right? So how long will it take an investment of 1,000, so that's my P, to double? What happens if you double 1,000? You get 2,000 and that represents A, the amount in your account. That's the amount you'd like to have at the end. And then your interest rate is 8%, which is outrageously good and probably unrealistic. Okay, so it's going to be R equals 0.08. And then it talks about is compounded quarterly, so that gives us another value, n equals 4. Remember that this says how long, so that means you're trying to find t. You shouldn't be able to plug in for t. Okay. So when I plug those things in, I get 2,000 equals 1,000 times 1 plus 0.08 divided by 4 raised to the 4t. So to me, that's essentially a problem from your homework. You have to solve for a variable that's in an exponent. How many variable exponents are there in your equation? 1. So use that first method we have in our notes. isolate the base, raised to its exponent. So I'm going to divide by 1,000. That's going to leave me with 2 equals 1 plus 0.08 divided by 4 raised to 4t. Now, I have no issue on this one if you write 1 plus 0.08 divided by 4 as 1.02 because that terminates, right? It ends, it comes out exactly. I would argue that, like, if we were doing divided by 365, and that was going to be a long decimal, to leave that as 1 plus 0.08 divided by 365, so I have an exact value there when I evaluate. There was a problem like that on your homework. I can't remember which one it was. But now I've isolated the base and the exponent, so I can rewrite it. My base is 1.02 or 1 plus 0.08 divided by 4. So I'm going to do log base, which is subscripted, 1 plus 0.08 divided by 4. It can be ugly like that. Okay. Of, go around the equal sign, so of 2. And remember, the answer to your log is always your exponent. So the exponent is 4t. Now, here is where we diverge, fork in the road, depending on your calculator. How do you evaluate the log? So if you can go to math and pull that log-based function, you might be able to change your base in your calculator. If you have, for sure, the 83, or I think most 84 silvers without the color screen, you have to know the change of base formula. So that's where you do the log of 2 divided by the log of the base, 1 plus 0.08 divided by 4. So I'm going to model this change of base one. If you know how to change the base in your calculator like I showed you back in section 3.2, you can do that. I'm going to pull up my calculator. Go ahead and clear it real quick. So I would type this. Log 2, close my parenthesis, divide by log of the base, which is 1 plus 0.08 divided by 4. And I get 35.002. And then divide all of that by, oh, I wrote 42. Lord knows why, sorry. I saw some people staring at me strangely, so now I know why. Okay. So then we want to take all of that and divide by 4, right? So then I'll divide this by 4, and you should have gotten, in my hand, divide by 4. 8.75 years. Okay? Sorry about that. Okay. So T equals 8.75 years. Okay, and that answers the question how long, right? That's how many years it will take. Okay, now continuously I think is probably my favorite version because it's just a little bit less work to write down. So that's going to be, still the amount is 2,000 equals 1,000 e to the 0.08t. I'm going to divide by 1,000 like I did in the other problem. So some of us may be thinking of some patterns here. If you're trying to double your money, it's always going to be 2 on the other side. So you might not have to write the amount and the principal. You just know it's going to equal 2. What if you were going to triple your money? What would happen right there? It would be 3 because you're dividing by the original amount. And then now you can rewrite it as a log. This time it'll be a natural log of 2 equals 0.08t. And then this time divide by 0.08. So can someone give me their years for compounding continuously? 8.66. 8.66 years. So when you compound continuously, that's more often than compounding quarterly. You would expect it to take less time because you're earning interest on more interest. So that makes sense. But it's not going to be like a super huge difference there because we haven't changed anything else. So you shouldn't expect to go from like 20 years to 8 years. If you do, you probably have a mistake. What questions do you have for me on that particular problem? Okay, so real quickly, there's 3 graphs and models at the bottom of page 1. If you want to jot this down, you can. These come from page 238 in your textbook. So if you want to write that down and look there later, you certainly can. Notice that the exponential growth and decay models are nearly the same. The only difference between growth and decay, whether you'll be moving away from your asymptote because your rate of change is increasing, or on the decay moving towards your asymptote because your rate of change is decreasing, is determined by the value of b, whether b is positive or negative. For both of those equations, a is kind of like in our interest formula, it's like our p, it's our initial amount. So you might want to jot that down. You can also think about that as the amount at time 0. So if you plug 0 into your formula, you should get A. B is what we call the growth rate. Now, if you're putting the growth rate into the formula, you would change it to a decimal. If you're taking the growth rate out of the formula, you would change it to a percentage. So it's just like the interest rate. And then these are the things that, like, for a particular model, these should be constant. Like, there is some initial amount and there is some particular growth rate. X and Y are the things that change or vary. They're your actual variables. Y just represents, like, your current amount at a given time. At a given time. And X just equals time. Now for these models, sometimes time may represent years and sometimes it may be days. It just kind of depends on the particular model. So there is the third model there I just want to point out to you. It's called the logistic growth model. I'm not sure which class it is. There's like an AP Social Studies. I don't know if it's geography or world history or something like that, but you discuss J-curves and S-curves. Anybody ever heard of that? J-curve, S-curve? Okay, yes? Okay, so the J-curve is exponential growth and exponential decay, where like it's just looks like a J and it's just shooting up forever, right? Realistically, that's not going to happen if you're modeling population. Like at some point, population is restricted by natural constraints. Space, food, right? Money, okay, different things. Those things are going to constrict population. So you may see a exponential increase in population, but then it will eventually level off. Like it hits like a max value, and it looks more like a stretched out S. So that's the S curve. For these models, really like, I'll give you the model. You just have to decide, like in the warm-up, whether you're going to plug in for X or you're going to plug in for Y and solve. Let's do the fruit flies example on the back. Okay, so this is an example of writing an exponential model. This is really important that you are practiced before tomorrow's quiz and before your test on Wednesday. So there's a good question about populations on your homework assignment that you should make sure to do. This is a research experiment with population of fruit flies. It's increasing according to the law of exponential growth. So that tells you which model to use. Y equals A times E to the BX. And remember, if it's growth, B should be greater than 0. After 2 days, there's 100 flies. After 3 days, or after 4 days, there's 300 flies. How many flies will there be after 5 days? Well, we need a model for that, right? So think about the information that's being provided to you. 2 days represents a time, which I just told you time was which variable? X. And the amount that you have at a given time represents Y. A represents the amount at time 0, but I don't think that I have that because I have 2 days and 4 days. So what I have here are 2 ordered pairs. 2 100 and then 4 300. So those are my X's and my Y's. If I know X and Y and what model I'm using, what could I do? What's that? Plug them in. Okay, so let's do that. Okay, if I plug in my first one, I'll get 100 equals A, E, and then it's B times 2, so I'm going to write that as 2B. If I plug in to the second one, I get 300 equals AE to the B times X, which would be 4B. And because neither of those have X that are 0, so I would be able to evaluate that. Anything raised to 0 would be 1, and I would have A, my initial amount. I have 2 equations with 2 unknowns, which means to solve for A and B, I'm basically going to be solving a system equation. So, pick one equation, solve for A. Solve for A in one equation. Doesn't matter which one you do. I'll just do the first one because it's right there. So I'm going to write 100 equals AE to the 2B. A is being multiplied by E to the 2B. How do I get A all by itself? Divided by E to the 2B. So A equals 100 divided by E to the 2B. I'd like A to be a number. Unfortunately, it's not because I don't know what B is. If I knew B, then I could find A. Okay, after I solve for A in one of the equations, what can I do? Plug it into the other equation. So I'm going to say step 2, plug A into the other equation. So that will be 300 equals 100 over E to the 2B times E to the 4B. Instead of A times E to the 4B, I'll just put 100 over E to the 2B in gray. It's a substitution. Okay, now if you're multiplying these two things, this is like E to the 4B over 1. You just multiply your numerator and multiply your denominator. So it's like 100 E to the 4B over E to the 2B. And then if you have things that have the same base and you're dividing them, what do you do with your exponents? Subtract. Where do you have more E's? In the top or in the bottom? Top, so we're going to subtract E to the 4B minus 2B in the numerator. So that's going to be 300 equals 100 E to the 2B. Whatever you want to say. Can you solve that equation? Yeah, now there's only one variable. It's just like the ones we did on our homework. Divide by 100. 3 equals E to the 2B. To get into that exponent, I'm going to need to use a logarithm. It's log base E, so it's going to be the natural log of 3 equals 2B. I'm going to divide by 2. Now, you'll need to put a few extra numbers after the decimal. If you're always rounding to the 10th or the 100th, you're probably rounding too close for a growth rate in an exponential model. So when I type natural log 3 divided by 2 in my calculator, I get point, and I'm going to go 4 numbers, 493. So I would say at least go to the thousands, maybe even the 10,000th place. Okay, it's a more accurate model. And that makes sense because we said it was a growth model, so B had to be positive, which 0.5493 is positive. Okay, now that you know what B is, what can you do? I can find A. Right? We said we could know A if only we knew what B was. Well, now we know B. So step 3, find A. So A equals 100 over E to the 2 times 0.5493. It's just like when you solve linear systems, after you find X, plug X back in to find Y. And so after you find B, plug B back in to find A. Okay, I get A equals 33.33. Now, some people might argue about that and say, well, that represents the initial amount of fruit flies, so I should round to the nearest fruit fly. I'll say this. In a model, it's very common to use decimals for things that should be whole numbers, like in terms of their initial amount. If you want to round to the nearest fruit fly, I would do that when I plug into the model to figure out how many fruit flies there are and give like a whole number fruit fly. So now I can write the model. Y equals 33.33 e to the 0.5493 x. And our original question was, how many fruit flies are there after 5 days? So we're going to plug in 5. Times 5, and I think it comes out to like 520 fruit flies. What questions can I address on that modeling question? Okay, again, I cannot stress enough to you the importance of doing the practice tonight. I do not expect my students in pre-calculus to be well prepared for quizzes or tests unless they do some of this modeling outside of this classroom. Okay, very few students, there are some, but very few students can just pick up right where they left off without doing any practice. So I would really encourage you, don't not do the population question. Please don't pack up. We still have 4 minutes. I would do the population question with the different countries on tonight's homework. Put that on your list of things to do. Now, the last example, we'll run through this one really quickly. We may not finish it all, but it talks about a college campus with 5,000 students. There's spread of disease, long-lasting flu virus, modeled by this equation. So it's the logistic growth model, and that makes sense. The flu is going to spread really fast for some time, and then once everybody's kind of been infected, that would be infected, it's going to level off. You're not going to have that growth rate anymore. And the college will cancel classes when 40% more of the students are infected. So how would you figure out how many students are infected after 5 days? Plug 5 in for T. I can tell you what that will be. Let me see if I can pull that up real quick. That should be, if you want to practice it later, it should be 54 students. The second question, probably the one that requires a little bit more thought, is after how many days will they cancel the classes? So what do you know about the college canceling class? 40% or more of the students. How will we figure out how many students that is? 40% of the 5,000 student population, right? So 40% of 5,000, that's 0.0 or 0.4 times 5,000, which is 2,000. 2,000 equals 5,000 divided by 1 plus 4,999 e to the negative 0.08 t. Okay, so this one, you got to be able to work with this logistic growth model. You obviously want to solve for t, which is trapped in an exponent, so at some point you're going to be using a log or a natural log here. But the variable is also in your denominator, so what would we probably do first? Multiply both sides by the denominator. So 2,000 times 1 plus all this stuff equals 5,000. You can divide by 2,000. I'm going to say 5 halves. You'll subtract the 1 from both sides. That'll be 4,999 e to negative 0.8 t equals, this will be 1.5. 2.5 minus 1. And then divide by 4,999. And I'm not going to do that. You'll write it out like this. But now I've isolated the base and the exponent, so I can rewrite it as a natural log. So that'll be natural log. Whatever 1.5 divided by 4,999 is equals negative 0.8 t divided by negative 0.8. And I think on this one we should get 10 days, approximately. Make sure you do your homework. Make sure you do that country's question. You will take your quiz at the beginning of class tomorrow.